Okay, for this question, we have a system of inequalities. We have x is greater than or equal to 5. So on our graphs, we want to trace over the line where x is greater than or equal to 5. So we can look at our choices here. And then we see that these two graphs at the bottom do not even have the line in the correct spot. So we automatically know that these are incorrect. Okay, if you have trouble deciding between like which direction the line goes, think about coordinates. If I picked a point on this line, the coordinates here are 5, 0. If I picked another point on this line, the coordinates here are 5, 2. If I picked this point, is 5, 10. They all have a 5 for the x value. That's how I know the line goes this way vertically and not horizontally. All right, now it says greater than or equal to 5. So where are the x values bigger than 5? X's are bigger than 5 over here on the right side, so the right side should be shaded in. So both of these graphs have the right side shaded in some way. Okay, the next thing I need to do is look at the y. It says y is less than -3. So I'm going to go down to -3 and I should see a dashed line. These are both dashed lines at -3. So those lines are in the correct location. Less than means I want y values less than -3. Y values less than -3 are things that are under this line. So I would want everything underneath here shaded. Now, it says which graph represents the solution set. The solution set is only where both areas overlap each other and are shaded. So this is the only solution set right here in this quadrant where it's shaded. This one contained all of this shading, but I needed to go back and then erase the part that didn't contain both colors. So A is the correct solution. Number 36. Number 36 says, what are the two solutions to the equation? We have a quadratic here. When we have a quadratic, in order to solve, if we have an x squared and an x term, we need to get everything on one side. So to get everything on one side, I would have to add 14 on the left and right side. I can't put the 14 with the other two terms because they're not like terms. This would give me a 0 on the right side. Now, as soon as I have that, I can make a decision. I can either choose to factor this expression and solve, or I can do quadratic formula. My advice is, if you're not good at factoring, use quadratic formula, because quadratic formula is on your reference sheet. Okay, your reference sheet contains quadratic formula here, and you have the entire formula given to you. Okay, in this particular problem, our A would be 1, our B would be -15, and our C would be +14. So these would be the values that we're plugging into quadratic formula. With our quadratic formula here, we would say negative, and then the B is -15. Plus, because we're going to have to do one question with a plus, one question with a minus, and then we would plug in the -15 again for the B, -4 times the A was 1, the C was 14, and then we're going to put it over to A. Now, we can type all that in at once if we use the online calculator. You guys have an online calculator option. It'll pop up on your phone, on your computer screen. The way you would want to start this is to type in the fraction bar first. Okay, we type the fraction in first, and then we're going to go step by step exactly what we have here. So negative, and then parentheses, -15, close parentheses, and then I put a plus sign, then I put square root, and then inside there I have -15 in my parentheses. I square that, and then I have -4, parentheses for the 1, parentheses for the 14, close those parentheses. In the bottom, I have 2 times 1. Okay, it gives me my answer of 14. That's one of my solutions. When we do quadratic formula, we have a plus sign and a minus sign, so I need both solutions. On your computer, it's touch screen, so just tap in there, backspace the plus sign, and type a minus sign. You got your second solution is 1. So the correct answers for this question are 1 and 14. It saved you a ton of time to use the online calculator. You didn't have to worry about order of operations. You didn't have to type it in twice. You just had to change that one little sign. Okay? So that's one way to do it. That's what I would recommend. Okay? So we have 14 and 1 for our answers. Now, if you were super good at factoring and you wanted to do this by factoring, you could ask yourself what numbers multiply to positive 14 and add to negative 15, and we could factor. So by factoring, we would have x minus 14, x minus 1 equals 0, and then we would set each factor equal to 0, and set the factors equal to 0, and we get 1 and 14. That is only if you remember your steps for factoring. And this one is an easy factoring question because A is 1. We can jump to the shortcut. Okay, when A is not 1, it's a whole other process and it takes more time. Okay, so quadratic formula works for all of these questions. That's why I recommend it. Number 37. 37 says a function f is given. Select the terms to describe the end behavior of the function. So end behavior means what's happening on the ends of our graphs, right? So this graph, because my A is positive, there's a positive 1 here, I know that my graph opens up. Okay, it's a quadratic, right, because of the squared. So I know my graph is going to look like this. So it says as x approaches negative infinity. When we think about our xy, this is my x, my y goes like this. This side is positive infinity, this side is negative infinity. For y, positive infinity is at the top, negative infinity is at the bottom. So it says as x approaches negative infinity, as x moves left, f of x, which is the same thing as y, what's happening to y? So as I go to the left on my graph, as I move left, I'm going up. So I'm approaching positive infinity. Okay? As x approaches infinity, so as x goes this way to the right, as I move right on my graph, f of x, which is the same thing as y, goes up. So that's positive infinity as well. So I'm picking infinity or positive infinity depending on if they have the plus sign in front of it or not on the EOC. Okay. Number 38. The expression the cubed root of 18 times 5 times the cubed root of 6 is equivalent to 15 times the cubed root of x. What is the value of x? So, for this question, since I have a cube root for both of these, when the roots or the index is the same, I can put whatever's under the radical together and whatever is outside the radical together. So there's really a 1 outside here, right? So it's 1 times 5, and then I have the cubed root, and then I'd have 18 times 6. Okay. Notice how my final answer here says I should have a 15 on the outside. That's telling me I'm not done with this. So I'm going to have to do some more work. So this index here, the cubed root, is telling me that I need to pick out 3 factors that are exactly the same. So if I think about these numbers 18 and 6, I want to think about their factors. 18 can be written out a couple different ways. Okay, if I break 18 down, I could say 18 is 2 times 9. and then I could break 9 down into 3 times 3. I can break 6 down into 2 times 3. So really, underneath this radical are all of these numbers. 18 is the same thing as saying 2 times 3 times 3. 6 is the same thing as saying 2 times 3. So if I rewrote this, I'm going to rewrite it under here because I don't have enough space. My 5's still out there. I'd have 2 times 2 times 3 times 3 times 3. It's a little bit more organized, right? I'm looking for a group of 3. The index tells me the group I'm looking for. Here's my group of 3. That 3 tells me these cancel out, and I put a 3 on the outside. These 2's are still left inside. That makes a 4 on the inside. On the outside, that makes a 15. So what number goes in this place? It's the number that's inside the radical. It's a 4. If that was completely confusing to you, this is a question I would not stress over. Okay. All right, number 39. Margot surveys 150 high school juniors and seniors about their favorite types of dipping sauce. She records the results in the table below. How many more high school juniors and seniors chose honey mustard sauce than sweet and sour sauce? So it is juniors and seniors together. So we want to put these together to get our total of 48. And then we want to compare that to the sweet and sour sauce. 11 and 12. So we have a total of 23 here. We want to know how many more. So I want to subtract these. 48 minus 23, and that's going to give me a total of 25. So 25 would be my final answer for this question. Number 40. It says the graph y of f of x and a table of values for an exponential function g of x are shown. Which statement correctly compares the graphs of the function? So for this problem, we need to understand that one of the big differences between linear functions and exponential functions is that exponential functions will always eventually be greater than the linear function because exponential functions increase at a steeper rate than the linear functions do. So no matter what the original picture looks like, when we are comparing linear to exponential, exponential will eventually be greater. Okay, so when I read through my choices, as the values of x increase, g of x will eventually be greater than f of x because g of x is exponential and f of x is linear. It's going to happen every time. So that's why we picked that option. Okay, if we wanted to look at options C and D, it says the value of the y-intercept of f of x is greater than the value of the y-intercept of g of x. So the y-intercept here is at 1. The y-intercept here is also at 1. So they're the same. One's not greater than the other, so C and D are both wrong. Okay. Number 41. Sanjay buys X boxes of hot wings and Y bottles of soda for a party. The numbers of boxes of hot wings and bottles of soda he can buy with $40 can be represented with the inequality shown. And we have an inequality here. Which graph represents all possible solutions for X and Y? So we can do a couple different things here. We could test some points. one point that's easiest to test, if we notice in our 4 graphs, 2 of them have 0, 0 shaded, and 2 of them have 0, 0 unshaded. That's going to be our easiest test. So if I plug in 0 for both, I'm going to have 40 is greater than or equal to 6 times 0 plus 2 times 0. The right side gives me 0. Is 40 greater than 0? Yes, it is. So I should definitely shade that point. I should shade in 0, 0. So these are wrong because 0, 0 is not shaded. Okay, the difference between these two graphs is one line is solid and one line is dotted. This symbol here with the bar underneath tells me I need a solid line. So I needed this solid line right here. The dotted line is incorrect. And that's it. Number 42. Janelle buys blackberries and raspberries to make pies. Blackberries cost $8 per pound. Raspberries cost $9 per pound. Janelle can spend a maximum of $40. Create an inequality to represent how many pounds of blackberries B and raspberries R Janelle can buy. So I'm going to write a B next to blackberries. I'm going to write an R next to raspberries. If I wanted to buy 1 pound of blackberries, I would say 8 times 1. If I wanted to buy 2 pounds, it would be 8 times 2. That B is what I'm multiplying the 8 by. So I'm going to put 8B here. The R is what I'm going to multiply the 9 by. I'm buying them together, so I'm going to add them. Now this part, Janelle can spend a maximum of $40. She can't go over 40. So whatever this equals has to be less than $40. Okay, it doesn't say she can spend 40, so I'm going to add the equal to bar. She could spend exactly 40, but all of this can't go over 40, so it has to be less than or equal to 40. Because if she hits 41, she doesn't have enough money. 43. Cynthia buys some tools. She creates exponential function D to predict the value of her tools after T years. She predicts her tools will have a value of 380 after 1 year and a value of 361 after 2 years. So we have after 1 year, 380, after 2 years, 361. Which equation represents the function B? Okay, so we could do a few different things here. If we look through our choices, we need to figure out an A value, right? And we need to figure out our R value, okay? After 1 year, it was 380. So we know we can't be starting with 380. When we do a formula like this, our A value is telling us where we're starting. So we can't start at 380 if it was after 1 year. So I know A and B are wrong. So now I only have to decide between, we know C and D are wrong. Now we only have A and B to pick from. One way we could do this is we could plug in the X value and see which one gives us the correct Y value. So if I plugged in a 1 here, we would have 400 times 1 minus 0.05 to the first. And I just need to plug that all into my calculator. Okay, so I could plug that in using my calculator that's on the computer. So if I use the calculator that's on the computer, I would just type in 400. I would do parentheses, 1 minus 0.05, close the parentheses, and I'm raising this to the first. My answer is 380, and that was what I was supposed to get. Okay. Now I want to check and see if it worked if I plugged in a 2. So when I plugged in a 2, I'm supposed to get 361, and that's that's what I got. I got 361. So the first equation works for both points. Now, if I wanted to double check, since it just happened to be A and it worked, I could plug in these other values. Okay, so when I plugged in 2 for this equation, I get 261. That's not what I was supposed to get. When I plugged in 1, if I change this value up here to a 1, I get 323. I was supposed to get 380. So B doesn't work. Okay, A is the only one that works. When in doubt, plug X values in and check for the correct Y. Okay, when they give you these. That's going to be an easy strategy to use. Number 44. The graph of a quadratic function is shown. Which equation represents the function? We notice all of these are in vertex form. Vertex form on your formula sheet is right here. Okay, our A value for all three forms tell us which way our graph is opening. So this graph opens down, which indicates I should have a negative A value. Negative, negative, positive, positive. C and D are wrong. Now I've got 2 to pick from. Okay, there's a couple things that are different about A and B. They both have the same Y value for the vertex, but they have different X values for the vertex. This has a vertex at -3, +4. What we have to remember about our formula is that inside the parentheses, we are switching the sign for our vertex. This formula has a minus sign here, so if I have a negative value, it's going to change it to a plus sign. So A has the correct vertex. There's another characteristic we can look at to help us. We know that our parent function, to get to our next point, goes down 1 over 1 or down 1 over 1. On this graph, it goes down 2 over 1, down 2 over 1. So that tells us we'd have to have a 2 out here for the A. So that was the other difference between these two that we could have looked at. Okay, and our final question, number 45. Select all the values that are equivalent. So this one is super basic. When you have radicals like this, you can divide inside, and this is the square root of 3. Okay, so this is a select all question. So this one works, right? The square root of 3 works. But now I have these other choices that I need to check. And if I'm not sure if any of the other ones work, I have my calculator that can do a lot of this work for me. So on my calculator, let me clear this out, we have the square root of 24 over the square root of 8. And if you forgot that you could divide inside there like that, no big deal. You can type that in and I get 1.73 if I round. Okay, so I can go through my choices and I can type in square root of 3, 1.73. That's the same. This one, I have a fraction. There's a 1 in the top. There's a square root of 3 in the bottom. This is, if I round, 0.58. So that's wrong. I've got the square root of 16 here. I know that answer is 4. So that one's wrong. This one, I've got 2 times the square root of 6 on the top and 2 times the square root of 2 on the bottom, which is 1.73. And then down here, I've got 4 times the square root of 6, and then I've got the square root of 8. So I've got 3.46. So this one is my only other one that worked. So those are going to be my 2 choices. So use your calculator to help you if you forgot your radical rules.